Okay, every tree is made up from edges and nodes. So here's the class that represents node. Every node have value and every node can have left and right child. So this represents an edge. If left or right is null, that means there is no left or right child. Under constructor, I have getters and setters. Nothing interesting. Getters return a value, setters sets the value to provided parameter. Let's look at the binary search tree class. This is the class that represents tree. You can see it have attribute called root. That is the only node that we need to store in here, because every other node is in the root's left or right subtree. So we have them stored in the left or right attribute of some node. I hope that makes sense. When we create new tree, the root is null. That makes sense because we haven't stored any value. Then there are three elementary functions: insert, search, and delete. Let's see how inserting works. So, user passes value that he wants to store, and we check whether there are any elements. If there are not, we create new node and set it as root. But if tree already contains some value, we go through this tree until we reach the future parent of our new node. That is what this while cycle does. So we start at root and we go right if the value that we are inserting is bigger. If it is smaller, we go left. If it is not bigger nor smaller, we end up the algorithm because the value is already in this tree. We stop when the variable current is null. That means that we found the place that we want to insert to. But we would like to get kinda one step back to get to the node above. Because in order to insert, we care about the parent. But thankfully, we were smart enough to store the parent into variable. That was happening at this line. After this cycle, we will have the parent, so all we need to do is add the value that we are inserting as its child. We still don't know whether set the value as a right child or left child. But we can simply find out by comparing the parent's value with the value that we are inserting. Now, let's look how search works. This search is pretty straightforward. We have a variable called current, and once again we have while cycle. So while current is not null, we go either left or right. Or we return true if search value is not smaller nor bigger than the value of our node. And if there is no node to follow, that means current would be null. And if current is null, we jump out of the while cycle and return false. Now let's look at deleting. We check whether the root is not null. If it is, we return false because we cannot delete the element. If it is not, we find the element. That is what this while cycle does. It's still the same trick as when searching and inserting. If value is smaller, we go left. If bigger, we go right. If we get to a null node, we return false because value that we want to delete is not in this tree. When this cycle ends in variable current, we have the node that we want to delete. And in the variable parent, we have node above the one that we want to delete. Now, as in the explanation, there are three possible cases. First is that the node that we want to delete have no child, in other words, is a leaf. If it is a leaf, we check whether it is root. If it is root, we set the root to null. And if it is not, we just set the left or right pointer of parent to null. Then we return true, because the node has been deleted. Case 2 takes place when the node that we want to delete have one child. If it have right child, we do the same as with leave, but instead of setting to null, we are setting to the right child. And if it have left child, we do the same, but instead of setting it to right child, we set it to left child. You may notice that we are not actually deleting the node. The node that we deleting is still somewhere in memory, but we delete the reference to this node by rewriting the left or right pointer from its parent. I hope that makes sense. The last possible case is that we want to delete a node that have both left child and right child. We get the biggest node from left subtree. I will explain in a minute how that works. We call this node successor. And we set its childs to childs of the node that we want to delete. This way, we kinda replace the node that we want to delete with successor, but we still have to change the reference in its parent. So we check whether the node that we want to delete is root. If it is, we set the root to successor. And if it is not, we set the successor as some child of the parent of the node that we want to delete. That way we rewrite the reference and kinda delete the node. Now, let's look on how we get the biggest node from left subtree. We store the left child of starting node to the parent variable, and we get the right child of parent to a variable called right child. This variable will represent the most right node, and we need its parent because we are actually deleting the most right node. Sometimes can happen that there is no right child in left subtree. In this case, we delete the node that is in parent's variable and return this node as biggest in the left subtree. If there are any right childs, we run into this while loop, where we do the same trick as before. After this cycle, in right child variable, we have the most right node, so all we need to do is delete it and return it. But do you remember in the explanation video I mentioned that the most right node can have left child? And we need to keep the left child or left subtree in the tree, right? And we do that by setting the right child of parent to left child of the most right node. But what if the most right child have no left node? Will this still work? Actually it will, because if there is no left child, the getLeft call will return null, right? And since if the most right child have no left child, we still want to delete the reference in its parent, right? And we do that by setting it to null. I hope that makes sense. As addition, I wrote the print function. This function prints the tree. It is just for you to check how the tree look like if you're not sure. If you want, you can look at the code, and as usual, if you do not understand something, just ask, and I will see you next time.